Okay, so now we're going to take a look at the second do not for week 1. So our first question says, based on the results of experiment 1, so I highlighted that because I know I'm going to be looking at experiment 1. If the concentration of F- in a solution is doubled, then the corrected conductivity will what? So if I go to experiment 1, where the results are in table 1, make sure that you're looking at the right experiment, not at experiment 2 on the next page. Now, I want to see the concentration double. So if we look at things that went there, so that's 1 to 2, 2 to 4, 0.5 to 1. We can look at those. I'm not going to look at measured conductivity, but I am going to look at corrected conductivity because that's what the question asked. So what will it do? This one went from 0.08 to 1.6. This one went from 1.6 or 1.7 to 3.3. And this one went from 3.3 to 6.7, 3.34. So if we look at what these did, these are also doubling. So that leads me to the only answer that I can use is for 35 is C, double. And you just get that from looking at the table. All right, 36. A sample was also taken from the drinking water supply of the community in experiment 2, and its conductivity was measured to be 20.69. So the measured conductivity was 20.69. Which of the following correctly lists the drinking water supplies of Newton, Lakewood, and Blue Water in increasing order? So that means we're going to go from smallest to least. So let's put that in order now, knowing that we have 20.69. So we have 16.46, 18.63, 19.47, 20.69, that's our new one, and then 22.31. And then let's look at where those go. So that's Springfield, that's Lakewood, Reading, I don't know how to say that, our new one, so that would be Blue Water, and then our last one is Newtown. So if we look at these, we have Springfield's not even on our list, so we can go ahead and ignore that. So we have Lakewood, Reading, which is also not on our list, so we can ignore that, Blue Water, and Newtown. So that means our answer is J. And you get all of that just by listing these in order from the figure. All right, 37. Based on the results of experiment 1, so that means that I'm going to be looking at experiment 1, if a solution with a concentration of 3 had been tested, the corrected conductivity, so we're going to look at corrected again and not measured on the table, would have been closest to which of the following values? So that means that we are going to pick a data point in between our values. So we want to know what it would be if we had 3. So 3 falls between 2 and 4, which means that our answer choice is going to fall between 3.34 and 6.68, and it'll probably be right in the middle. So if we go back to our answer choices, 1.3, no. 3.3, that's below it. 5.0, and 6.5. So our answer is going to be C. And you get that just from looking at the figure. On the interim, this was actually one of our high scores. All right, let's do 38. So if experiments 1 and 2 were repeated, that means this is an SIN question because it's going to ask you about methods. To measure the concentration of chloride in drinking water, which of the following changes in the procedure would be necessary? So that means we have to go back and actually look at the procedure. So 5 solutions, each containing a different amount of Na2SiF in H2O were prepared. 5 identical electrodynamic cells, that's a control, were filled with equal volumes of each of the 5 solutions, that's another control, and a 6th identical cell was filled with a blank solution. That means that's your control group, not a control variable, but a control group. The cells were activated to measure the electrical conductivity for each. So we don't really want to change the methods, but we need to have chlorine in there. We don't have any chlorine in that compound. So that means that we need to actually have Cl instead of F somewhere. So let's go through our answer choices. The solutions in experiment 1 should be prepared by adding different concentrations of NaCl, so that's an option. The conductivity of the blank solution should be added to the measured conductivities. That's just a control group. The electrodynamic, nope, because we just want to measure chlorine. We don't want to change it from resistivity. And then both NaCl and Na2SiF, nope, because that would only give us one or the other. So our answer choice is F, because that's the only one that keeps all of the controls that you need. All right, 2 more. So 39 says, based on the results of experiment 1 and experiment 2, if the measured conductivities for the samples tested in experiment 2 were compared with their corrected conductivities, the measured conductivities would be. So if we look here, we have some different F- concentrations in our measured conductivities. Here, let's look. Our measured conductivity is a lot higher than our corrected conductivity in all of these. So let's check our answer choices. So the corrected conductivity is calculated by subtracting the measured conductivity of the blank solution. And that means that the corrected conductivity is always less. You actually get that from the last line of the passage, so that we know this answer is going to be B. The measured conductivity is higher. You can get that from the passage without looking at the data, or you can look at the chart and see how those numbers compare, like we did just a second ago. All right, and finally, number 40. The presence of other negative ions, such as Cl-, results in an increase in the electrical conductivity of a solution. If all of the samples in experiment 2 contain trace concentrations of Cl-, how would the measurements have been affected? Compared to the actual F- concentrations, the F- concentrations apparently measured would be what? So the answer here, which we just gave in the passage, you don't actually have to look, is higher. It says Cl- results in an increase in the measurement. So that means the ones that get measured would all be higher. All you need to know is that increase means higher for this question.